My name is Joonas. I'm a maintainer of a CNCF incubating project called WASM Cloud, which is well, I'll talk about it in just a second. And then I'm also a software engineer working in a company called Cosmonic, which for this purpose of this talk is not relevant. So let's talk about meshing with WebAssembly, taking Linkerd beyond containers. So just as a quick show of hands, how many of you are familiar with WebAssembly? Kind of, sort of, maybe? All right. We got, let's say, 30% of the audience. So bear with me. I'll just kind of give you a quick whirlwind tour through what is WebAssembly. So you can think of WebAssembly as kind of like a tiny VM. The idea is that you basically take a bunch of different source languages. Using their language-specific tooling, you can compile them down to the WebAssembly bytecode or to a binary target. That's the .wasm module here. And then what you can do with that .wasm is you can run it on basically any WebAssembly runtime. And that could be something that's running on a server, could be running on an edge, could be running on a phone, IoT device, or it could be running in a browser. But the nice thing is that you take your code, you compile it once, and it can run on a whole bunch of different architectures without you ever having to think about it again because of that the representation in bytecode as a binary, WebAssembly binary. So you might be asking, like, why should I care about WebAssembly? Well, here's a couple of reasons, and these are the properties that made WebAssembly originally interesting for the browser, or these were specifically designed with the browser in mind. But it turns out that these are also properties that are really interesting on the server side. So the first and foremost, the important thing about WebAssembly is that the security model WebAssembly has is one where instead of taking permissions away, you actually add only the permissions that the binary needs to execute. So this capability-based model is essentially flipping the security model of containers on its head. So it's inverting that model. The second thing that makes it really interesting is the zero cold start. So these things start in microseconds, sometimes less than a microsecond, and they scale down to zero when they're not executing. So you basically have no running processes, and they start instantly when you need them to start. Another really interesting property is when you compile your software to a WebAssembly, it's typically measured in hundreds of kilobytes or single-digit megabytes, unless you're doing an interpreted language where you end up actually compiling also the interpreter into the WebAssembly. In those cases, it's usually in the tens of megabytes. And then finally, as I mentioned, the bytecode, the WebAssembly binary is portable across architectures. So you compile your code once to WebAssembly, and now you can run it anywhere that has a WebAssembly runtime. So that's pretty neat. Now, as of about a year ago, there's this new, I'm not sure what to call it. I'll call it a standard. But essentially, it's a new set of technologies on top of the core WebAssembly spec called WebAssembly components. And what that allows you to do is you take your WebAssembly module, you describe the imports and exports it has through this IDL called WIT, WebAssembly interface types, which looks a little bit like protobufs, if you're familiar with protobufs. And what that allows you to do is basically you can take WebAssembly components that are written in different languages, and you can combine them using their explicit imports and exports. So what you get in the end is actually a component that is composed together of the different ingredients or the smaller components that are in it. And in this case, we have a Rust and a Go binary that are just talking to each other without knowing what language the other component is written in. It doesn't matter because the WebAssembly host is doing the translation when they're trying to talk to each other. So that's a really interesting way to be able to write software in multiple languages. So if you could imagine, you might have a library that's written in C, and you want to use it in, let's say, Python, JavaScript, something like that, and you don't maybe have an FFI available for it. Well, WebAssembly is one way you could actually start using it if you're compiling both of your those components into WebAssembly. So, as I mentioned, I'm a maintainer of a project called WASM Cloud, which is a WASM native orchestration platform. You can kind of think of it as essentially Kubernetes, but for WebAssembly components. And where we differentiate is that we can go beyond just the Kubernetes space. So the idea is that we can scale from all the way from your on-prem data centers to the edge, IoT edge, browser edge, things like that. So you might be wondering, why is that relevant for the purposes of this talk, right? We're in Linkerd. When we're inside of Kubernetes, which is actually the common place where we see our customers and end users in the community deploying Wasm Cloud, the question often becomes like, hey, so I have these WebAssembly components, and they're trying to talk to things. How can I get all the benefits that my containers are getting when they're running inside of Kubernetes? And as you might imagine, the answer to that question is, well, you add a service mesh. And since we're talking about Linkerd here, I happen to be very partial to Linkerd for a number of reasons. So what I did is went ahead and went through an evaluation to understand, like, hey, so if we're trying to run WebAssembly components, what does it look like to use Linkerd? And honestly, I was a little disappointed because it just works. Like, you have to do basically nothing, right? Great, end of talk, right? When you look a little bit under the covers of the Wasm Cloud host, what you'll realize is that there's all these little, let's call them VMs, tiny VMs executing inside of the runtime, right? So let me see. Okay. So what happens is you now have a whole host of different programs, multi-tenant programs. So you have a multi-tenant host that could be running tens, hundreds, thousands of different components, different applications that are all behind a single IP address, a single identity. So that's where things get a little exciting. Now, the good news is, when I went through this, I started making sure that I'm making the most of all the primitives that Linkerd makes available to you. And initially, I was a little skeptical. Can I actually make this work? And what I kind of came to the conclusion of is, like, yeah, all the design decisions that have been put into Linkerd in terms of how it integrates with the larger ecosystem and what are the extension points it makes available to you, you can actually get vast majority of the benefits of Linkerd out of the box, as long as you're configuring things correctly. Now, there's a couple areas where I think there's some room for improvement, or let's call it opportunity to do deeper integration. Specifically on the security side, one of the things I would love to be able to figure out is, when you're trying to do policy control or authorization, things like that, is there a way for us to represent the underlying component that is executing the WebAssembly application's workload entity as part of the policy decisions that are being executed by the Linkerd proxy? I understand that there's an integration with Spiffy and Spire, so that's something that we've actually started integrating within Wasm Cloud as well. And so I'm hoping that we might be able to find a way to actually tie the two together and actually start using the shared workload entity as a way to enforce policy. And the other thing is observability. So you might see all these requests coming from a single process in the host. And it would be really nice to be able to drill down into an individual component and understand, like, hey, it's talking to a bunch of stuff. How can we measure that? So at this point, I was like, okay, well, that wasn't very exciting. But I thought about another thing. Well, what if we brought Wasm to Linkerd rather than Linkerd to Wasm? So a thing that my CTO says a lot of times is, Wasm is really the last plugin bundle that you'll ever need. So I went looking, and in the issue tracker, there's a bunch of these. I was cherry picking some issues that felt like a good fit. There's a few issues that I thought, that could be an interesting extension point. What if users had the ability to write some functions that could be executed by the proxy to extend the functionality that the proxy has? So I went ahead and looked up a few of these issues. There's some opportunity there. I'd love to talk to the Linkerd folks about that, but we'll see. And then the other thing I'll just kind of finish up on is there's this emerging pattern in the WebAssembly space called the platform harness. And the idea is that as an end user, as an application developer, you have your own component. But you also have, on the platform side, the platform team might be maintaining a component that essentially satisfies all imports and exports and allows your component to actually talk to the outside world. So when you put these things together, they become just a single component that has a single export. In this case, we have WASI HTTP, which is a way to talk to the outside world using HTTP. Now, The common use cases for this that you see in the community today are things like observability, policy-based authorization routing, retry circuit breaking, et cetera, et cetera. That sounds familiar, right? Well, what if we could have Linkerd compiled to WASM as a component, as part of your platform harness, and just servicing these things next to your application? So I'll leave you all with that. I appreciate your time. If you want to talk more about WebAssembly, we have a booth at the Project Pavilion, 6B. Not entirely sure where that is, but there's a bunch of maintainers around. Would be happy to talk to you. And then also on the Cosmonic side, we have a booth, and we'd also love to talk to you about WebAssembly if that's of interest. So thank you. Hello. So if anybody has any questions, I'm happy to chat with you afterwards. I think we want to just get us set up with the next speaker. So thank you.